Welcome to the course Data Mining and Knowledge Discovery. Today's our topic is Knowledge Discovery. Myself Priyanka Gupta, working as Assistant Professor in Department of Computer Science and Engineering Data Science at Institute of Aeronautical Engineering, Dundigal, Hyderabad. Let's get started. Today the topics I'll cover. The first topic is what is data and information. What is data warehouse? What is data warehousing? Data warehouse characteristics. What are the different characteristics of data warehouse? Data warehouse architecture. What is the whole architecture of data warehouse? Multidimensional data model. What is fact and dimension, right? And we'll also discuss about what is the difference between both of them. Multidimensional representation and what is schema and other type of schema. What is data and information? So data is an individual unit that contains raw materials which don't carry any specific meaning. So data is an individual unit that contains the information, right? So that don't carry the specific meaning. What is information? Information is a group of data. So information is nothing but the group of data that collectively carries a logical meaning. So from the group of data, we can fetch the information, the useful information, right? So that data does not depend on the information, right? Because data is a single unit. Data is an individual unit from which we can, which contains the raw materials some of the data types. So data does not depends on the information, but the information depends on the data. Why? Because this is a group of data, right? So data that the some measurement is there. Data is measured in bits and bytes. Bits and bytes, right? So the data is measured in bits and bytes. That is nothing but the computer language information, right? So the information is measured in meaningful units like time and quantity. Some of the example are time and quantity. So that is the time is having some type of a group of data. So the time is the information only. Data warehouse. What is data warehouse? Data warehouse is like a relational database. So as if we know about what is database before going to the data mining subject, so we can understand it is same like the relational database, right? So in that it is designed for the analytical needs. So it is basically the data mining we are doing for the business purpose. So here we need to calculate some of the analytical calculations, right? So we need a relational database that works on that. So that the data warehouse is nothing but the relational database that is designed for the analytical needs. It functions on the basis of online analytical processing, right? OLAP. OLAP is nothing but the online analytical processing. So for the data mining, we are using the OLAP servers. So on which we can do the these of the all calculations, analytical processes, right? So data warehouse is a central location where the consolidated data from the multiple locations, like we can say databases, are stored. So as in the figure we can see here some of the database, we can see the database is someone shown here, right? So here we can see summary data, raw data, metadata, right? So what is data warehouse? Data warehouse is like a relational database designed for the analytical needs. So if we know about the database system, we can understand what is relational database, right? So the data warehouse is nothing but the relational database which is used for the analytical needs. So in that, it works on the basis of the OLAP. What is OLAP? Online analytical processing. So while we are doing the data mining, we are using data warehousing to store all the data, but the that is only working on processing on the OLAP server, that is online analytical processing server, right? So data warehouse is the central location of the data where all the consolidated data from the multiple databases it is stored. So in this figure we can see the data warehouse is shown here. So that is a combination of databases, different databases. So here the metadata is there, raw data is there, summary data is there, right? Here we can see the process is the different sources will be there of database, right? Of different data sources from where we have taken the data, right? So that is nothing but the operational data, that is the real time data. The operational database is nothing but the real time database on which we are working, right? So also the flat files are there. So flat file is nothing but the single table data. So all of the database sources that is going to do the ETL process. So in before the storing the data, all the data onto the data warehouse, the ETL process is going on. So what is ETL? ETL is extraction, transformation, and then loading. So here the data will be extracted, then it will be transformed, and then it will be loaded into the data warehouse. So data warehouse is nothing but the relational database, and in that many types of data will be stored, right? So that will be extract, transform, and then will be loaded on the data warehouse. So in the data warehouse, the metadata is there. So what is metadata? Metadata is nothing but the directory of data. The directory of data, which is denoting the multiple data warehouse objects, right? So it is denoting the multiple data ware objects. Here summary data, so that is related to the data summary, right? So that contains the all of the data summary, right? Raw data is nothing but just it has been stored after the extraction, transformation, and loading before the processing, right? So now after this we will process the data, right? We will process the data. Processing will be here after the data warehousing. In the data warehouse, the data has been stored, and while we will do the processing on differently processing, then for that we can have some of the results, like we can have the online analytical process analysis. We can also get the reporting of the data. We can also mine the data for our use, for our, like if the industry is using this data, so they can mine some of the useful data as information, and then they can use for their own purposes. So that was all about the data warehouse, how the database data is storing in data warehouse, and what is the all related functions of the data warehouse. What is data warehousing? Data warehousing term. So data warehousing is the act of organizing and storing the data in a way, right, so as to make the its retrieval efficient and insightful. So the warehousing is nothing but it is the process to store the data, to retrieve the data. For that we can have the useful insights. After that we can have the we can get the useful information to plot the data, to visualize the data, to for the data mining purposes and the for the reporting purposes. So while we are using the online analytical reports, right? So it is also called as a process of transforming data into the information, right? So that is the process of transformation of data, that on the basis of that we are getting the information, useful information, so that we can use it for the visualization as well as for the reporting, right? So here in this figure we can see the data warehousing process. So here what we can see, the source systems. What are the data sources are there? These are the nothing but the data sources, different data sources. After that, the ETL process will go. What is that? Extract, transform, and loading. After that, the all of the data that will go into the staging area. So here the data will wait and rest, and after that again we will process the data warehousing system is processing the data for which we can face the useful data. Again it will go into the ETL process, right? Again it will go for the ETL process, and then it will be stored as in the data warehouse as well as in the form of data marts. So here we can see the new term data mart. Data warehouse was the relational database, that is nothing but where the companies or industry are storing the data, the business data, and for the online analytical processing. But what is data mart? Data mart is nothing but it is the data warehouse of the one single business, that is depends on the one only subject, one area. If we are having the suppose we are having the business data that is related to the somewhat we can say footwear, so the all the data will be stored in the one single data mart, and uh, and all the whole data will be stored in the data warehouse, right? So that was the difference between the data mart and data warehouse. Again all the data will go into the stage OLAP server. It will go to the OLAP server. OLAP server is nothing but the online analytical processing server. So here the data will be organized, and then the data will be processed. After that we can retrieve the data in the form of information, useful information in the form of some charts, some of the bars, some of the graphs, and some of the reports. So this was all about the data warehousing processing. What are the data warehouse characteristics? So we are having some of the characteristics. Let's see. A data warehouse is a subject oriented, integrated, time variant, and non-volatile collection of data, right? So a data warehouse is nothing but the collection of data. So but here's the some terms are there: subject oriented, integrated, time variant, and non-volatile. So the collection of data in support of management decision making process. So we are storing all the industry is storing the data, all the business industry is storing the data into the warehouse, but the data for to fetch the useful information, we are having the some of the data. We are using the some of the data. So why we are using that data? Because we can have the some decision. The companies can take decision on the basis of users, on the basis of customer, on the basis of their we can say sales, related to their sales. So they, on the basis of that they can take the decision, they can have the future analysis, so that what they have to do on the order of their sales, on the order of their customers. So for that decision making, the data warehouse data they are using. So the data warehouse is nothing but the collection of data in support to take decision process, right? So here the term is subject oriented. So in for that, a data warehouse can be used to analyze a particular subject area, right? So that was all about that. One data warehouse will depend on the particular one subject or one area, right? So here, for example, for any of the company, the sales can be a particular subject. So that we can call as the data warehouse is a subject oriented vision. What is integrated here? A data warehouse that integrates data from the multiple data sources. So as we have seen in the processing part, the data sources were there, right? Different data sources were there. Then after that, we have seen the ETL process were processed. ETL process were applied, right? So in that, here the many data warehouse will be there. Many data warehouse will be there, right? So that in the process of ETL, they will be combined. They will be integrated at a one place, right? So that is nothing but the integration of the data. And after all of the processing, while it is processing through the OLAP servers, after the end, we are also getting the integrated data. So that is the nothing but the, here we are using the data as an integrated part. Time variant is nothing but the historical data is kept into the data warehouse. So as we know, we are having the relational database. That is nothing but the database. In that we are storing the data. The companies, business companies, they are storing the data. So the data can be of old time, that can be a historical data also, that can be a new data also. So only the data is nothing but the historical data of somewhat. So historical data is also we are keeping in the data warehouse. So we can see in the example, for example, one can retrieve data from 3 months, from 6 months, 12 months, even older data from a data warehouse. So for suppose if some of the e-commerce company is there and they want to analyze what is the sales growth in the month March, in the month February, so they have to take the data from that particular month and they can analyze the data. Either they can also have analyzed the 1 year data of the based on the same sales, right? So we can use the historical data for analysis also. This contrasts with the transaction system, where often only the most recent data is kept. So some of the we can see some of the transactional data are also there, right? So some related to banking system. If some of the relational data is there, transactional data are there, so that is nothing but because transactional data is updating on the real time. So that will be the most recent data. So like this, in data warehouse, the historical data is there, but some of the time the transactional data is also will be there. Non-volatile. What is non-volatile? That data, once the data is in the data warehouse, it will not change. So once we are storing the data into the warehouse, once the companies are storing the data into the data warehouse, the state of the data will not change. That will be the same, right? So that was nothing but the non-volatile in the character. So non-volatile in the character. So historical data in the data warehouse should never be altered. That will not change. So data will be saved in the data warehouse will be same all the time. Data warehouse architecture. What is the architecture of data warehouse? We will see that data warehouse is having the three tier architecture. The first bottom tier is the data warehouse database server. That is the almost always a relational database system. So the data warehouse server is the first tier, is in the first tier, right? Bottom tier. So in that, the backend tools and the utilities will be used to feed the data into the bottom tier from the operational database, or we can say from the sources. So in the first stage, what we have seen in the processing, what we have seen in the block diagram of the data warehouse, there we have seen the external sources, data sources were there. So and also the operational databases were there. So the data warehouse and data sources and data systems, database systems that will be applied to the, that will be feed to the bottom tier level, right? So that is nothing but the bottom tier of the architecture, right? So some of the tools will be used for that, some of the backend tool and operational tools will be used for that, right? So the tool will be perform the ETL process. That is nothing but the data extraction, cleaning and transformation, right? So here what the tools they are applying, what is doing that? They are merging the similar type of data from the different sources into the unified format. As we have seen that data we have told as integrated, right? Data warehouse has said as integrated. So what is integrated? Here after the ETL process, we need to, the system will need to merge the similar type of data into the from the different sources into the one format. So that is nothing but the after the ETL process the system will get, as well as the ETL process will load and refresh the functions to update the data warehouse after the each ETL process. So that was the processing of ETL process. So that will these are the things will happen in the first tier of the architecture of data warehouse. The data will be extracted using the application program interface. What that is? That is gateway. That will be used by gateway. So these are the processing will be went through with the gateways. So a gateway is nothing but it is supported by the underlying database management system, and that is allowing the client program to generate SQL code to be extracted at a server. So while we are extracting the data, we at the relational database level, we need to write the user, we can say the it is related to the business data, right? So some of the person will be assigned to write the SQL code for that. So the SQL program will be written and that will be supported by the DBMS, the underlying DBMS system. So then it will be executed at the OLAP servers. So that will be happen in the bottom tier level of architecture. So here we can see the figure of the three-tier architecture, right? So here we can see we are having the operational database, that is nothing but the real-time data, right? And the external sources, some of the data, all of the combination of database. So here the ETL process will go on. So in that the after ETL process, the the data will be stored in the data marts in the form of data warehouse. It can be supported by metadata repository. It will be monitored. It will be administered. So the bottom tier is nothing but the data warehouse server. So after the ETL, these are the processes will go on. After the bottom tier, the data that will be processed, that will go to the OLAP servers for the next processing. OLAP servers. So that is on the OLAP server level, the middle tier architecture will be happen, right? So after the loading of all the data onto the OLAP servers by the tools, the output will be shown at the top tier. So that is nothing but the front end tools that will be shown on the front end tools by the visualization techniques. So that we will get into the form of output. That can be the query report, that can be bar charts, graphs, that can be data mining of the data. So this was the architecture of data warehouse. In that, the bottom tier were there, middle tier were there, and top tier were there. So in the bottom tier, the data warehouse server were there. The middle tier, the OLAP server were processing the data, and at the top tier, to visualize the data, we are having the top front end tools. Right? Data examples of gateways. So what was the gateway in the bottom tier? The gateway was nothing but that was the relational database. That was the connection. So that includes the ODBC. What is ODBC? Open Database Connection. That is nothing but the Open Database Connection, and the OLDB. OLEDB. OLEDB is nothing but the open linking and embedding for databases. So that is introduced by Microsoft, and one also is there, gateway is there, JDBC, that is introduced by Java Database Connection. So that are the gateways we are using at the bottom tier for to process the data for the ETL process. That is nothing but the extract, transformation, and load. In this tier, we also contains a metadata repository. So that we have seen, that is also supporting the metadata repository. So that is nothing but what is metadata? That is a directory of data. So that is storing the information about the data warehouse and what are their objects, or we can say content. So it is a directory basically that is storing the information about the different objects of data warehouses, right? So in the middle tier, that is an OLAP server we have seen in the figure. So that is having the two types of models. So first model is a relational OLAP model. The relational OLAP model, that is an extended relational database management system. That is nothing but the extended form of relational databases management basis. So that maps operations on the multidimensional data to standard relational operations. So here the term comes multidimensional. So what is that? So to view any type of like data, we can have some types of views. So we can have the 1D view of data. We can have the 2D view of data. If we are having the table, so we can have the column and rows. If you are having the 3D data, we are having the X, Y, Z axes. So the multidimensional data will be processed in the on the OLAP. So that is nothing but the extended relational based database management system that is mapping the operations on the multidimensional database data to the standard relational operations. So here that after the data will be viewed as multidimensional, that will be processed by the using of relational OLAP model. Second model is a multidimensional OLAP model. So what is this? It is a special purpose server, that is nothing but a server that is directly implementing the multidimensional data and operations. So that was the relational OLAP, and that is the multidimensional OLAP. So that will be used in the middle of the middle tier of the architecture. In the top tier, that is a front and client layer, that is a front and client view. In that, that is containing the query and reporting tools. So to visualize the output, to visualize the result, some of the reporting tools and some of the query processing tools are there. Some of the analysis tools are there. Some of the data mining tools we can have to visualize the trend analysis and to have the prediction of the data which we have taken from the middle layer, from the architecture of data warehouse. Multi-dimensional data model. So what is multi-dimensional data model? So as the names tells all the things, a multi-dimensional model views the data in the form of data cube. So what is data cube? Data cube is nothing that is having the logical view of the in the 3D model. So here, if we can see some of the data cube will be looks like this. Data cube will look like this. So that is nothing but the data cube. So when the data is grouped and combined into the multidimensional matrices, that is called as a data cube. So for example, I'll show you in the next slides how the data is storing in the data cubes. So some of the matrices will be stored some of the information, some of the data. So the group of data, the group of matrices, that is combined into the data cubes. A data cube enables data to be modeled and viewed. So the data cube is modeling the data, and after that we can view the data in the form of multi-dimension. So that is the nothing but the 3D dimension of the data. So it is defined by dimension and facts. So the data we can see onto the multi-dimensional level, that is having the dimension and facts, some of the characteristics. These are the characteristics. A multi-dimensional data model is organized around a central theme. So what is multi-dimensional data model? So that is having the multi-dimensional data, right? So that is having the data cube model. So in that, the data will be organized into the central level. So for that, for example, if you are having the sales data, the theme will be represented by a fact table. So for example, here will be a table that will be shown by the sum of the tables. That will be the fact table, and the data will be shown by the sum of the related tables. So that is nothing but that is the multi-dimensional data model. So here we can see the dimension of at the another levels. So the data model is organized around a central theme. This theme is represented by a fact table, right? So what are the facts? Facts are nothing but that are numerical measures. So for the data which can be measured in the form of numerical measure, that is nothing but the fact. So right. So what is fact table then? Fact table is nothing but that contains the names of the facts or measures of the related dimensional table. So what I have seen you in the example, this is a some fact table, right? Or here the facts will be shown, right? So here related data will be shown in the form of another other tables. So that is nothing but that is having the name of facts, that is having the name of measures, right? In the dimensional tables. Fact versus dimension. So fact, or we can say also measure what you want to analysis in your facts. So what is measure actually? We have to analyze in our part that is called as a fact or measure. So, for example, if you are having, if the some of the industry, some of the company that is measuring the what is my sales. So if they are measuring them, what is my sales, what is my profit, what is my custom preferences. So this type of terms will be called as a fact, a measure of the data. What is dimension in that? In the multidimensional view, by which you want to analyze in your dimensions, right? So by which we want to analyze in our, what are the dimensions are there, right? We can see an example. For example, sales by location, a product, and by period. So that is nothing but the different dimensions. Sales can be increased by location, sales can be affected by product, sales can be have in the particular period of the time. So that was nothing but the different dimensions of the time and we can say location, product, item. So we can say total profit by the location, profit, and period. So that is nothing but the dimensions of the data. So how it is different, we can see here the multidimensional representation of the data cube is there. That is nothing what I have told you. The data cube is a 3D representation of the table. So here we can see, here we are having the time ID, we are having the PID, right? And some of the here we are having the, and the third axis we are having the LOC ID, right? So here we are having some facts. These are the facts. These are nothing but the facts, right? So that is a view of the data cube, one single data cube. In the tabular format, in the 2D format, we can see the same of the data is stored in the form of PID column, time ID column, LOC ID column, and sales. So here we cannot see sales. So how we can measure the sales? What was the facts here? What was the facts stored in the one particular data? What is this? Data cube slice. Data cube slice. So in one slice, what have been stored, that is called that is stored in the 2D table as a in the column of sales, right? So here we can check whether the 2D data is there, whether the 3D data is there, how they are differentiate. So here we can see for the PID 11, the time ID is having 1, 2, 3, the LOC ID is same, and the sales column is having the 25, 8, and 15 numbers. So that was the 2D representation, and yeah, we can say the tabular representation of the data, right? That was the nothing but which is more than the 2D representation. That is nothing but the multidimensional view of the data, representation of the data. In that multidimensional representation, each of the dimension may have a table associated with it called a dimension table, right? So as in the previous example, we have seen the data cube is there. So that will be related to the sum of the logical table, that is nothing but the dimension table, which is further describes the dimension of that particular we can say slice, right? So consider, for example, the 2D table is there, that is have the location Delhi, that is having the location Delhi. For the location Delhi, the 2D table is there. In that we are having the columns, time, quarter, item type, we are having different items, we are having egg, milk, bread, and biscuit. This is the nothing but the data of a shop for items sold per quarter, per 6 months they are having the items sold from the city Delhi. So in that we can see how the data is stored in the form of 2D, we can say tabular, in tabular representation. So here the dimension table is nothing, we will see in the multi-dimensional view of the data. In this 2D representation which we have seen, the sales from the Delhi are shown for the time dimension, organized in quarters. So in the in the table we can see what that has been shown. That is nothing but the Q1, Q2, Q3 and Q4. So what is this? These are the time quarters. In the first quarter, the sales of the egg was 260. The milk sale was the 508. Bread sale was 15, and biscuit sale was 60. So for the for a year, the data is like stored as in the form of quarters. So for the 3 months, the data thus the items has been sold by the particular shop in the one quarter, like in the 3 months, that was the these values. So like that, that is the one dimension of the data, right? So that was the time dimension actually. What we have seen in as a quarters, Q1, Q2, Q3, Q4. And for the item dimension, that is classified according to the types of items sold. So which we have seen as a column, the different types of like items were there: eggs, milk, bread. So that is nothing but the item dimension of the same of the particular table. So the fact or measure displayed in the form of rupee sold in the thousands. So the what are the facts are there that we have seen in the example that was displayed in the form of rupee sold. Earlier table, what we have seen, the 2D dimension, 2D representation of the table. So for that, we have seen the time dimension, that is denoted by the quarters. Different quarters were there. I will show you. In this, we are having the Q1, Q2, Q3, and Q4 quarters. So that is nothing but the time dimension of the each of the table, each of the rows. So on the basis of that, we can say that was the dimension of the data, that the time, right? And the item dimension, we have seen the bread were there, right? Bread were there, milk were there, right? So that is nothing but the item dimension of the same table, right? So the fact or measure that is displayed in the table, some of the facts were there, some of the facts were there in the table. These are nothing that is stored in the table as a data. So that is nothing but that is stored in the rupee sold, that is in the thousands. If we want to view the sale data with the third dimension, for the example, suppose the data according to the time and item, as well as with the location is considered for the city like Chennai, Kolkata, Mumbai, and Delhi. So these are the 3D data is shown in the next table. So that 3D data of the table are represented as a series of 2D tables. So we have seen the data of the city Delhi, but now we will see the 3D dimension of the same table. So for that, we are having the cities like Chennai, Kolkata, Mumbai, and as well as Delhi. So here we can see the 3D table. So this is the 3D dimension of the table that is having the location Chennai, Kolkata, Mumbai, and Delhi, right? So also we are having the time dimension, that is Q1, Q2, Q3, Q4. Here we have what we have told this is the item dimension. So this we have store as a item dimension: egg, milk, bread, and biscuit. So this is all for the all of the 4 cities. So that is nothing but this is the 3D table of the same representation, same table, which is having the 3 more dimensions on that: Chennai, Kolkata, and Mumbai. So we can say it may also be represented by the same data in the form of 3D cube. So what are the data were there in the 3D table? So we can also see in the, this is the nothing but the I was telling you, data cube. That is the 3D view of the some of the table, some of the 2D table, 3D table, right? Here we can see on the x-axis we are having the item, right? And the y-axis we are having the time, that is stored in the quarters. So item is having the types, that is egg, milk, bread, and biscuit. The quarters are having the Q1, Q2, Q3, Q4, and the third vertical, that is that is saved in the form of location, of you can say in the form of city. Different cities are there: Delhi, Mumbai, Kolkata and Chennai. So the facts stored here, that was from the 3D table of the same, right? So that is the 3D representation, that is a multi-dimensional representation of the same table. What is schema? So we have covered the we have covered the multi-dimensional representation of any data table or table. So now the what is schema and in the relational database. So schema is a logical description of the entire database, entire data warehouse. So we are measuring all the things for the data warehouse here. So the schema is the logical description, right? It includes the name and description of records of all the record types. That includes the all of the associated or related data items, and that aggregates them, right? So in the schema, all of the description will be there, all of the names will be there, and in the form of records that will be associated and aggregated. So we can say we have seen in the database, a data warehouse also requires to maintain a schema. So in the database management system, we are also the system is also maintaining the schema. Here the same thing happens, that requires to maintain a schema of the database. So the schema, a database use in the database we are using the relational model. In the data we are using the star, snowflake and fast constellation schema. So these are the different logical views of the same database management system. So that if you are having some database, so we need to show them in the terms of some visualization. So that will be shown in the form of star schema, we can say snowflake schema, fact constellation schema, right? So the modeling of the data warehouse will be shown in the form of dimension and measures, that we have shown in the earlier example, right? So the dimension of the modeling of the data warehouse will be based on the dimensions and measures of the same, right? So what is star schema? So first example of the relational model, the star schema is there. So in that, a fact table will be in the middle. So what is fact table? Which is having the sum of the facts, some of the data stored on that. So in the table we have seen some of the facts were there. Like if we are having the some table, we are having some of the like columns, name, right? Name, age, gender, like that. So if we are having the name here, right? We are having the, suppose Amit, Akshay, and some of the ages like 52 to 21, like that. Gender, male, right? So these are the nothing but that is stored as a fact. These are the values are called as a fact. So the table in the table where the facts will be stored called as a fact table. So in the star schema, the fact table will be in the middle of the whole architecture, right? So that will be the middle, that will be connected with the different dimension tables. So the related table will be shown as a dimension table, somewhere here. So that will be related to the same of the fact table, right? So the star schema looks like the star. So that on the basis of that we call as a star schema. Snowflake schema. So snowflake schema we can see in this example. So first we will go through with the what is snowflake schema. Or refinement of the star schema, right? So that is the better version of star schema, where some of the dimension hierarchy is normalized into the set of smaller dimension tables. There were big tables that were having all of the information of the fact table, but here we are although here that is dividing into the other small tables, other dimension tables, that is a forming like a shape that is looks like a snowflake. So on the basis of that, we are calling as snowflake schema. In this figure, in this example, we can see here we are having some of the tables. So here city dimension, customer dimension, we are having employee, department, product category, product dimension, sales, and dimension. So sales is nothing but that is a fact table of this example. So that is a fact table. These are the dimension table that is related to each other. So here also that will be extend that in the star schema, that will be stopped here. The dimension table that will stop here, but here we are giving the extension small tables of the different dimension tables at each of the label, right? So that is nothing but the star snowflake, that is a snowflake data schema, right? What is fast constellation schema? In that, multiple fact tables that is sharing the dimension tables. So that is nothing but here many of the multiple of the fact table will be used. So that will be viewed as a collection of stars. So for that we can also say it as a galaxy schema or fact constellation schema. So the facts will be constelled here, so that we are calling as a fact constellation schema. In this example, we can see the fast constellation schema, that is it is having the fact table sales. For that, it is having the time key, item key, branch key, location key, unit sold, and dollar sold. The dimension table, it is having the dimension, the item, the location dimension table, the branch dimension table, and type dimension table. But that is also having the measures, that is nothing but the measures. So the fact table that has been stored as a, I'll show you, that has been stored as a, right. So in the fast constellation schema, we can see here the multiple tables has been sold. So that is nothing but the one table. So there will have some other tables also that will be related to these dimension tables. So that was the first one fact constellation table that is having the sum of the measures, right? So we were not having the for this measure also one table will be there. For this measure also one table will be there, like that. So all of the and also with that one dimension table will be associated. So that is nothing but the fact constellation table of the schema. So today I have covered what is data warehouse, what is data warehousing, what are the multiple architecture of data warehouse, what are the characteristics of data warehouse, some of the important facts, some of the some of the terms related to the data warehouse, and other some of the processing of the data warehouse, and what are the different logical view of the data warehouse. So we will complete with the this schema. We will go through into the detail of the schema in the next slide, next course. So today we have completed the data warehouse. What is data warehouse? What is data warehousing? What are the processes of data warehousing? What is the levels of data warehouse? And some of the what is the architecture is divided into the data warehouse process. What are the different logical view of the data warehouse? So that was all about the introduction to data warehouse. We will meet into the next video. Thank you. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.